here we go, jumping back into 5.2 slope fields. I have example 9 here. We have a slope field that was given, and we need to figure out which statement is true for all solutions. So for x is less than 0, all solutions are decreasing. So it looks like this is the set of axes there. So when x is less than 0, that would be on this side, are all the solutions decreasing? No, that's not true. See, they're going up there. Nope. All solutions level off near the x-axis. That's true. Look, they're all kind of leveling off there. That looks like that's true. For y greater than 0, so we're talking about anything there, all solutions are increasing. Yeah, that's true. All right, so it looks like letter D. All right. The slope field for this differential equation will have vertical segments when? Okay, so the slopes would be vertical when the derivative is undefined, or when 4x plus 2y equals 0. All right, or 2y equals negative 4x, or when y equals negative 2x, which happens to be one of our examples. So see, you can sometimes have multiple choice questions that are pretty simple if you know what you're doing. Okay, another multiple choice. If y is greater than 0, and I'm going to just trace this axis, make it a little easier to see. There we go. If y of 0 is greater than 0, so we're talking about somewhere up here, then the limit as x approaches infinity is 0. Definitely not. Look how steep that's getting. That's definitely not true. Okay, it's actually approaching infinity, not 0. All right, if this time we're talking y is between 0 and negative 2, so there. Limit as x approaches infinity looks like it's going towards negative 2. Well, yeah, that kind of all evens out there, right? That looks fine. Now let's check this. We're going to check this part. Y of 0 is less than negative 2. Then the limit as x approaches infinity is going towards 0. Yeah, that looks like that's... Oh, that's not 0, is it? That's negative 2. So no, that's not true. Ooh, almost tricked me. So it looks like our answer would be B, 2 only. All right, so we can see multiple choice problems, or maybe we'll see open-ended problems. So usually if you have a slope field problem, the first thing that you're going to do is have to graph a bunch of slopes. So you would want to try to graph that. All right, so if you notice some patterns, if x or y is 0, the slopes are 0. That's good. I'm going to do some math. Boom. Okay, that was fast. So I have the slope field. You can figure it out yourself too. All right, so we had to sketch a slope field. Did that. Usually on a free response problem, you're only going to have 6, maybe up to 10 slope values. You wouldn't have this many, but let's look anyway. Write an equation for the tangent line to the curve going through the point 1, 1. All right, so my tangent line, I'm going to call it L of x. All right, so what is this slope? dy dx evaluated at the point 1, 1. Well, that would be 1/2, and the point that we're going through is 1, 1. So 1 plus 1/2 times the quantity x minus 1. We're going to estimate, that's our q, to use approximately equal. So that'd be 1 plus 1/2 of 1.2 minus 1. 1.2 minus 1 is 0.2, half of that's 0.1, so 1.1. So that's what we're going to estimate the value of f of 1.2 to be, even though we don't even know what f is. We used our tangent line. All right, so now we're going to find the particular solution. So we have dy dx equals x times y divided by 2. Can we separate those variables? Sure can. 1/2 x dx. So we separate it. Now we integrate. Ln absolute value of y equals x squared plus c. No, it's not. It's 1/4 x squared, isn't it? Yeah. Okay, so now e to the 1/4 x squared plus c equals absolute value of y. Remember, we can move that c to the front and get rid of the absolute value. C e to the 1/4 x squared. Oh, I don't have to write the plus c anymore, do I? 1/4 x squared because I put it in the front. There's our general solution. Now we need to find, using our initial condition, at 1, 1. Oh, why did I write A of t? Oh, okay. At 1, 1. We get 1 equals c e to the 1/4. So c equals e to the negative 1/4. I'm going to go ahead down here. So y equals, if I have e to the negative 1/4 times e to the 1/4 x squared, I can actually have my equation be e to the 1/4 x squared minus 1/4. Okay, there's my particular equation. And so if I tried to find f of 1.2 using my, let's label that f of x, and if you plug it in, I think that you get 1.116. So that was pretty close to our original value, which is what part D is asking us for. I'm going to erase this so I could write there. Compare your estimate. The estimate was 1.1. The actual value was 1.116. Now, so part B was an underestimate, and let's use the slope field to explain why. At 1, 1, if we draw a little sketch of what this might look like, our function, our solution, is concave up. So that means any tangent line is going to lie below. So it's going to give us an underestimate. All right, so the rest of the problems in the notes are just free response type problems. There's a lot of them, and they can be time consuming. So they're going to be done in the notes. If you want to look at them because you feel like you need more practice than what the worksheet can give you, you're welcome to look at the notebook, but I think this is good for the videos.